Unit 18, spot, seam, and projection welds. Although several welding processes may be used to make spot, seam, and projection welds, they are generally classified as resistance welds. The process of resistance welding joins metals by using heat produced from the resistance of metal to electric current passing through the parts. The parts are normally held together under pressure during the entire welding process. Figure 18.1 shows a resistance spot welding machine, and 18-2 shows the projection welded fastener. The nut on the left has been projection welded to an automotive part. The nut on the right is about to be welded. Note the projections of the base of the nut. Spot welds. Spot welds are made between or upon overlapping members. Coalescence or melding of materials may begin at the mating surfaces or may proceed from the outer surface of one member. Spot welds may be made by any of several welding processes: resistance, arc, projection, electron beam, etc. With a spot weld, the welding process is indicated in the tail of the welding symbol, figure 18-3. When a spot weld is specified, the welding process is indicated in the tail of the welding symbol, TIG welding. The location of the spot weld symbol is in relation to the reference line of the welding symbol, may or may not have an arrow side or other side significance. Refer to figure 18-4. The location of the spot weld in relation to the reference line may or may not have an arrow side or an other side significance. No arrow or other side reference for or significance resistance spot. Size and strength of spot welds. A spot weld is dimensioned by either size or strength. Spot weld size is the diameter of the weld at the interface zone, point where members are joined. It is expressed in fractions, decimals, or millimeters. Spot weld size is shown to the left of the weld symbol. Spot weld size is placed on the left side of the weld symbol, 0.03. Spot weld strength is indicated in pounds or kilograms per spot in tension. It is also shown to the left of the welding symbol, 18-6. 100-pound minimum acceptable shear strength per spot. Spacing of spot welds. The pitch of spot welds is indicated to the right of the weld symbol, 18-7. Center to center spacing of spot welds is given to the right of the weld symbol, 2. Extent of spot welding and number of spot welds. When a series of spot welds is specified for less than the full length of a joint, the extent of the welds is dimensioned as in figure 18-8. Study the weld symbol when a series of spot welds is specified and the welds are to take up less than a full length of the joint. Also shown with the weld symbols is the number of welds required. Number of spot welds. If a specific number of spot welds is needed for a particular joint, the number of welds is given in parentheses on the same side of the reference line as the weld symbol. Study the weld symbol when a series of spot welds is specified and the welds are to take up less than full length of the joint. Also shown in the weld symbol is the number of welds required. The location of a group of spot welds on intersecting center lines is indicated as shown in figure 1810. Flush spot weld joints. The flush contour symbol is added to the weld symbol when specifications require the exposed surface of either member of a spot weld joint to be flush. Figure 1811 shows an example. When specifications call for the exposed surface of a spot welded joint to be flush, the flush contour symbol is added to the welding symbol. Multiple member joint spot welds. With multiple member joint spot welds, the same spot weld symbol is used regardless of the number of pieces inserted between the two outer members of the required joint. Seam welds. Seam welds are continuous welds made between or on overlapping members with coalescence starting at the mating surfaces or proceeding from the outer surface of one member. The continuous weld may be a single weld bead or a series of overlapping spot welds. A seam weld, like the spot weld, may be made by any of several welding processes. The process to be used is indicated in the tail of the welding symbol as shown in figure 18-12. The location of the seam weld in relation to the reference line may or may not have the arrow side or other side significance. The seam weld symbol location in relation to the reference line may or may not have arrow side or other side significance. Size and strength of seam welds. Seam welds are dimensioned by either size or strength. Seam weld size is designated as the width of the weld. It is expressed in fractions of an inch, decimals, or millimeters. Seam size is shown to the left of the weld symbol. Figure 18-14. The size of the seam is given as the width of the weld as expressed in fractions of an inch, decimals, or millimeters. There, size of the seam. When used, seam welding strength is designated in pounds per inch of weld or in metric units. This information is also shown to the left of the weld symbol. Length of the weld of the seam welds. Seam weld length when indicated on the welding symbol is located to the right of the weld symbol, figure 18-16. It is used on a welding symbol. Seam welding length is to the right. Length of the seam, weld size on the left. A seam weld extended less than a full length of the joint dimensions as shown in 18-17. Study the dimensions of the seam weld extending less than the full length of the joint. The pitch of an intermittent seam welds is given as the distance between the centers of the weld increments. Figure 18-18 gives an example. The pitch is shown on the right of the weld length dimension. Pitch of an intermittent seam welds is shown to the right of the weld length dimension. Orientation of seam welds. Unless otherwise indicated, intermittent seam welds are understood to have length and width parallel to the axis of the weld. Figure 18-19. Flush seam welds joints. The flush contour symbol is used when flush seam weld joints. The flush contour symbol is used when the exposed surface of either member or each member is to be finished flush. Figure 18-20. Multiple joint seam welds. No special addition to the welding symbol is required when additional pieces are inserted between the two outer members. Projection welds. A projection weld is produced from the heat created by the resistance to the welding current flow. The process of projection welding can be performed by resistance welding or through an arc process. Generally, a large amount of current is passed through a small performed area on the metal projection. Projection welding is used to weld many different types of parts together. Threaded fasteners such as bolts and nuts, concrete holding studs, and crosswire products like fence are all projection welded. Figure 1821 shows a projection weld MIG wire reel. The crosswire welding process is used to weld together. The reel is a form of projection welding. A cross-wire welding process was used to weld together a MIG wire wheel. Projection welding is used, the projection welding symbol requires the welding process referenced in the tail of the symbol. Figure 1822 shows a welding process reference PW in the tail of the welding symbol. The symbol must also be placed either below the reference line on the arrow side or above the reference line on the other side. The symbol may not be placed in the center of the reference line as permitted for spot welding. Stud welds. A specialized type of projection welding is stud welding. Stud welding is a general term used to describe joining a metal stud to a workpiece. Studs may be in the form of threaded fasteners, concrete holding studs, or other forms. Figure 1823 shows an example of the performed area on a .250-20 UNC or quarter-inch nominal diameter, 20 threads per inch, unified national course thread form, threaded stud. The heat produced by the resistance of the metal to the current causes the perform to melt. Pressure from the projection welding gun forces the projection fastener, stud, etc. into the molten pool of metal. The pool solidifies around and under the projection and fuses it to the base metal. Figure 18-24 shows projection welded fasteners joined by a capacitor discharge stud welding machine. Side significance. The stud welding symbol has arrow side significance only. The weld symbol should only be placed below the reference line with the location of the stud clearly indicated. Figure 1825 shows the stud weld symbol. Stud size, spacing, and number of studs. The diameter of the stud is given to the left of the stud weld symbol. Figure 1826 indicates a half-inch diameter stud. Spacing or pitch distance of the studs is indicated to the right of the stud. The weld symbol should be only placed below the reference line with location of the stud clearly indicated. Shows the weld symbol, the diameter. Figure 26 indicates a half diameter stud. Spacing or pitch distance of the studs is indicated on the right side of the symbol. 827 shows 0.38 stud spacing and 3-inch pitch. The number of studs to be shown in parentheses and placed below the stud weld symbol. The symbol shown in figure 1828 requires 8 studs. Location of the stud welds. Location information for stud welds is given on the print using standard dimensions. Generally, the center of the first stud is given from a datum or part edge, and often the last stud is also dimensioned. The distance between the centers of rows of studs may also be provided. Figure 1829 shows 2 rows of studs required for an assembly.